Welcome and greetings to students of KCT-Civil Engineering students. Today we are going to deal about the topic on the 2D state of stress at a point in a strained material. What is called as a strained material? In the case of material, any material, either a material of aluminum or compound material, steel or aluminum or copper, if you are applying the load, definitely there will be a state of stresses and a strain. So in the case of 2D or 3D, we can able to analyze what about the state of the stresses and strain, and from that you can able to find the principal stresses and principal strain, and also the shear stress and maximum shear stress. So based on the coordinate which is given in the direction of the applied force. Now I am going to take about the 2D state of stress. So what is called as a 2D state of stress? If you are finding the stress in the x and y direction, it is called as a 2D state of stress, or you can take YZ directions or ZX directions also. Only two direction of the coordinate axis we can able to take. But in the case of 3D, you can take all the three coordinates like x, y and z direction. So in the case of 2D state of stress, we are going to deal about what is called as a principal plane, and what is called as a normal plane, and what is called as a shear plane. So in the case of plane, that is a principal plane is the plane in which only the normal stress is acting and the shear stress is negligible or it is not also going to act. In the case of shear stress, we are taking only about the tangential or the shear force taken into account, but we are taking the x and y direction as the 2D directions. I am calling as the force in the x and y direction as Fx and Fy, and the corresponding the normal stresses acting on the x and y direction as sigma x and sigma y. So which is measured in terms